Friends, good afternoon. Welcome to the chemistry class. In this class, we will discuss about the chapter D and F block elements. Okay, D and F block elements. So, what is the definition of D block elements? The elements in which the differentiating electron enters into D subcell of the penultimate shell, that is n minus 1 D subcell, are usually called as transition elements. These elements belong to group 3 to 12 of the periodic table and constitute a separate block called D block in the periodic table. Okay, this is why these elements are also referred to as D block elements. They are all metals and show several interesting properties. They are very useful elements and find a variety of applications not only in our day to day life but also in industry. Okay, the element in which the differentiating electrons enters into the n minus 2 f, f subcell are called inner transition elements, and these elements have been grouped into two series called lanthanoid series and actinoid series and are placed separately at the bottom of the periodic table as shown in the figure 8.1. Okay, these series constitute a separate block called F block in the periodic table. Therefore, the inner transition elements are also called as F block elements. Okay, in the forthcoming discussion we shall study the important characteristics of transition elements. Okay, we shall also study some important characteristics of lanthanoids and actinoids. Okay, now, so in the periodic table, group 3 to 12 are called D block elements, and at the bottom of there are two series, that are lanthanoids and actinoids, which are put on the bottom of the periodic table. Okay, now the transition elements or D block elements. Firstly, we will discuss about the D block elements or transition elements. So first is position in the periodic table. So as we know that the elements belonging to D block of the periodic table are usually called transition elements, and D block is situated in the middle of the periodic table between groups 2nd and 13 as shown in figure 8.1. It is usually flanked by S and P block in the periodic table. That's why the name transition gives to the elements of the D block because of their position between S and P block elements. They are called as transition element because they are put between S and P block elements. On the other hand, the elements belonging to P blocks are electronegative and have a tendency for covalent compounds. The D block elements show a transitional behavior between the two, that is between highly electronegative S block elements and weakly electropositive P block elements. This is why the elements of D blocks are referred as transition elements. Now, classification of transition elements. The transition elements are D block elements classified on the basis of n-1 D subcell, which gets filled up in a particular class of these elements. On this basis, transition elements have been classified into four horizontal series called transition series. Each series correspond to the filling of particular n-1 D subshell. Okay, so first transition series are 3D series. So this series contains 10 elements which belongs to scandium to zinc, means atomic number 21 to 30. Okay, second transition series are 4D series. This series involving the filling of 4D subcell and consists of 10 elements from yttrium to cadmium, atomic number 39 to 48, and these elements lie in the fifth period in the periodic table. Next, third transition series are 5D series. This series involves the filling of 5D subcells and consists of total 10 elements. Lanthanoid, atomic number 57, and those from hafnium, atomic number 72. to mercury atomic number 80, and these elements lie in 6 period in the periodic table. Next, the fourth transition series or 6D series. This series correspond to the filling of 6D subcell. The series consists of the elements AC atomic number 89 actinium and those having the atomic number 104 and above. These elements belong to the 7th period of the periodic table. Okay, so you can see here electronic configuration of transition elements. So first 3D series, for 3D series you can see here the electronic configuration of scandium atomic number 21. Electronic configuration, outermost electronic configuration will be argon 3d1 and 4s2. So in this the d orbital contains only one electron. For titanium, in d orbital 2, vanadium 3, chromium 5. Okay, 4s1 and 3d5 due to half field stability. Okay, it is an exception because chromium at place of d4 contains d5 electron, because in half filled orbital condition this will be more stable, so it will contain this condition, not this. Okay, now chromium, manganese 3d5, iron 3d6, cobalt 3d7, nickel 3d8 and copper 3d10. It should copper is also an exception. The configuration should be 3d9 and 4s2, but it will not, it will be 3d10 and 4s1, because one electron of 4s will transfer to d orbital of this to obtain their stable configuration, means full filled d orbital. Okay, and in zinc there is 3d10 and 4s2. Okay, now 4D series, it contains yttrium atomic number 39, in which the last electron will go into d orbital, in which 4d orbital. At the above we have seen that the electron will go in 3d orbital, but in this the electron will go in 4d orbitals. 4d1, 4d2, 4d3, it will also an exception, and due to obtain their stable electronic configuration 4d4 and 5s1, molybdenum 5, 6, 7 and so on. So it is 3d and 4d. And 5d series, lanthanum 5d1 and 6s2. Hafnium, hafnium is a F block element, so the last electron will go in F orbital. Okay, and in D there is 6d2. Okay, next tantalum 6d3, 5d3, 5d4, 5d5 and so on. Okay, now fourth transition series, actinium atomic number 89, radon 6d1, 7s2, like then rutherfordium 6d2 and 7s2, dubinium atomic number 105, the configuration will be radon 4f14 and 6d7. Okay, seaborgium atomic number 106, 14 and 64, 65, borium, hafnium 6d6. So we can see here that according to the series the electron will go in 3d, 4d, 5d and 6d, last electron. So they are called as d block elements, due to which they are called as d block elements. Okay, now come to the definition of transition elements. So transition elements are those elements which possesses incompletely filled d orbitals in their ground state or in their ion existing in chemically significant oxidation states. Okay, in the light above definition, let us examine the elements of first transition series. Except copper and zinc, all other elements have partially filled d orbital in their elementary form or ground state and are true transition elements. Okay, copper possesses completely filled d orbital in its elementary form. Its common oxidation states are +2 and +1. The electronic configuration of copper plus 1 ion oxidation state plus 1 and copper 2 plus ion oxidation state of plus 2 as follows. Okay, Cu plus, because the last 4 electron will remove from this, then it will come into 4 Cu plus 1, and when both the electrons of 4s orbital will be removed from the copper ion, then it will come in Cu2 plus oxidation state. Okay, both copper and copper ion have completely filled d orbitals, however copper ion possesses partially filled d orbital. Therefore copper can be regarded as transition element only in the form of Cu2 plus ion, that is in plus 2 oxidation state. Now let us consider zinc. Zinc after removal of 2 electron will convert into Zn2 plus ion, and in this condition it contains 10 electrons in their d orbital. So zinc is not an transition elements, because according to the transition element definition, the element should have incompletely filled d orbital. Okay, so from this confusion it is clear that neither zinc nor Zn2 plus ion possesses partial filled d orbital, hence zinc cannot be regarded as a transition elements. Okay, so similarly the last elements of the second and third transition series, that is cadmium and mercury, also lack partially filled d orbitals both in their elementary form and in their common oxidation states of plus 2, as is clear from the following. Cadmium, d orbital have 10 electrons, cadmium 2 plus 10 electrons. Mercury, d orbital have 10 electrons, mercury 2 plus ion, d orbital has 10 electrons. So they are also not regarded as transition elements. Okay, now hence it may be concluded that the end member of all three transition series, means zinc, cadmium and mercury, are not transition elements in the true sense, because they possess completely filled d orbitals in their elementary form as well as in their commonly existing ions. In fact, zinc, cadmium and mercury do not exhibit the general characteristic properties of the transition elements and behave quite differently from the rest of the elements belonging to the d block of the periodic table. Okay, thank you. Have a nice day.